Zeal Education Society, redefining excellence.
Hello friends, my name is Chinmay Deshpande. I am from Department of Electrical Engineering, belongs to Zeal College of Engineering and Research, Narhe, Pune. In this video lecture, we are going to discuss about working principle of three-phase induction motor. Now this is what is a diagram. Here, three-phase AC supply is given to the stator. So this will be stator and this will be your rotor. Now, how that torque is to be produced and how that rotating magnetic field is to be produced, let's discuss one by one. Whenever a three-phase AC supply is given to the stator winding, the resultant current generates a magnetic flux, that is a phi. Now, as here three-phase AC supply is given, so it produces three independent magnetic fluxes. The resultant of these three fluxes is called as a net flux. Now, this will be a net flux which will be generated because of three-phase AC supply given to the stator winding. Now, due to the switching sequence of a three-phase current in all the three phases, that is R phase, Y phase and the B phase, that particular net flux will start rotating. The generated rotor flux or generated flux will be rotated in the circular manner around the rotor conductor. Whatever the magnitude of the net flux is there, it is same, but the position is continuously keep on changing as it is a three-phase supply. So this net flux will develop a magnetic field which is called as a rotating magnetic field. So therefore, how that rotating magnetic field looks like, so this will be a rotating magnetic field which will be produced whenever three-phase AC supply is given to the stator winding. The speed with which this rotating magnetic field rotates, this is called as a synchronous speed, that is ns. Now, the conductors of the rotors are stationary initially. This stationary conductor can cut the rotating magnetic field of the stator. And we know that from the Faraday's law of electromagnetic induction, because of that, if the conductor is stationary and the field is continuously rotating or changing, the EMF will be induced in the rotor. Whatever EMF which will be induced in the rotor is called as rotor induced EMF. It is because of mutual induction action. And here this phenomena is called as electromagnetic induction phenomena. Whatever conductors which are placed on the rotor, already we discussed in a construction that conductors are short circuited with the help of end ring. So therefore, what happens in that case? So as it is short circuited, so there will be current will start to flow through it. The relative motion which will be there between the rotating magnetic field and the rotor conductor, it will induce a current in the rotor conductor. As the current flows through the conductor, the flux will induced and the direction of the rotor flux is same as that of your rotor current which will be induced in the rotor. Now, we have two fluxes. One is because of the rotor and another is nothing but because of the stator. So these fluxes will interact with each other. Now as the flow of a current in the rotor conductor, the force will be experienced by the conductor or on the rotor, and therefore this phenomena induces the torque on the conductor. Whatever torque which will be generated on the conductor because of this, the torque is called as electromagnetic torque. Now here the current will start flowing. This is what is the direction of a current which is shown. Now, whatever direction of the electromagnetic torque and the rotating magnetic field is there, it is the same. So therefore, the rotor starts rotating in the same direction as that of a rotating magnetic field. The speed of the rotor is always less than the rotating magnetic field, which is also called as a synchronous speed. The speed of the rotor is always less here. You will ask me question, why the speed is less? So we will understood this after completion of a working principle. Now in short, how I can remember? First, the three-phase AC supply is given to a stator winding. Now because of three-phase AC supply is given to the stator winding, the current will start flowing through a stator winding and it will produce a rotating magnetic field. Why rotating magnetic field? Because here we have considered three phases and each phase will produce its own flux, that will be a net flux, and it is continuously changing with respect to time. So therefore, it is also called as rotating magnetic field. the stator magnetic flux rotates at a synchronous speed whose formula is given by Ns equal to 120 F upon P, where F is the supply frequency, Ns is the synchronous speed, and P is nothing but a number of poles. Then the magnetic flux passes, or we can say that cut the conductors on the rotor, and it induces a voltage or the EMF in the conductor. It is because of Faraday's law of electromagnetic induction. Since these conductors which are there in the rotor are short circuited with the help of end rings, so therefore current will start to flow through it. The rotor current will produce its own magnetic field which rotates in the same direction as that of a magnetic field, that is stator magnetic field. So this is what is a working principle of induction motor in a short form. Now the rotor current will produce the torque which sets the rotation. Now the question is, why the speed of the rotor fall behind the Ns? Now here you will observe that as soon as the three-phase supply is given to a three-phase stator winding, the current will start to flow, and because of that current it will create its own field, and that field is nothing but, we can say that it is a magnetic field which will be rotating as it is a three-phase. So therefore it will rotate at a speed, that speed is nothing but a synchronous speed that we already discussed. Now this rotating magnetic field will get linked to the conductors which are there in the rotor, and therefore because of that it will create its own field. Here you will observe that the conductors are short circuited, so current will flow through that, and the EMF will be generated as far as electromagnetic induction. Now whatever EMF which will be induced in the rotor, it is called as a rotor induced EMF. Now here what you will observe, what is the cause and what is the effect? Why EMF will be induced in the rotor? It is because of the three-phase AC supply which is given to the stator. So here the cause is nothing but a stator magnetic field, and whatever effect is nothing but a production of a magnetic field in the rotor. So there has to be some time lag between these two fields which will be produced at a stator side and it will be rotor side. So therefore to the stator first it will create its own field which will be rotated at a synchronous speed Ns, and after that whenever it gets linked to the rotor, there is a time lag between these two fluxes which will be produced, or these two fields which will be produced, and therefore it also rotates. Whatever rotor induced EMF produced, it also rotates with its own speed, that is called as a rotor speed, which will be Nr. So this is the reason why that particular Nr or speed of the rotor is less than that of the synchronous speed Ns. Just you have to remember, here cause is the stator magnetic field which will occur first, and after that the effect will be seen which will be on the rotor, that is nothing but production of a magnetic field in the rotor. Now this lag causes the rotor to rotate at a speed that's somewhat slower than that of a stator field. Hence your answer for question is, that's why here the rotor rotates at a less speed than that of a synchronous speed, that is speed of a stator magnetic field. So this is what is the picture that I have shown here. So you will get here idea. What is the idea behind this? This concept holds an analogy which will give you clear idea about synchronous speed Ns and the rotor speed Nr. Now here whatever this donkey is there, it is the rotor magnetic field, and the yellow can is the stator magnetic field, that is rotating magnetic field. Now as this person is there at this position, so whenever donkey moves in the forward direction, this is what is the distance which is maintained here in between this yellow can and in this donkey. So this donkey represents what? It will be rotor magnetic field which will be fall behind to this particular yellow can which will act as a stator magnetic field. So this will be analogy with the help of which you can easily understood why the rotor never runs at a synchronous speed. When we discuss about a torque equation of a three-phase induction machine, then you will be able to understand this concept in more detail. What happens if your Nr and Ns becomes exactly same? So I will tell you only in one line. If your Nr and Ns becomes exactly equal, then in that case slip will be equal to 0, and as a slip will be equal to 0, the torque which will be required for the rotation of the rotor or the conductor, it will not produce. So that we will discuss when we see the video for torque equation of a three-phase induction motor. So this is what is about a working principle of three-phase induction motor. Thank you.
Zeal Education Society, redefining excellence.